In the last program, we learnt about the use of control structures to write small decision-making programs. But sometimes large amount of data has to be handled. Such data items are grouped in an array. In this program, we will introduce to the concept of arrays and various types of arrays. Memory allocation to arrays, in-depth knowledge about how to feed data in array and how to access an array. In the previous modules, you have learnt about data types, variables and control structures available in C++. I hope you have been practicing with decision-making programs. Most of such problems include manageable number of variables and data. Suppose you have to find average of 100 numbers and sort them in ascending order. Can you do it? Yes, but how? Will you declare 100 different variables to store 100 numbers so that you can sort them? That's not intelligent and efficient way. C++ has a solution for this. Use of arrays can solve your problem. Not only this, you must be playing 3D computer games or have been architects making the blueprints of buildings, visualizing them, or scientists simulating a model. Do you know what is array? Array is a set of elements of same data type represented by a single variable name. Array can hold a few data or thousands of data. Only need is to declare an array with its type and dimension. Each element of an array can be referred to by specifying the array name followed by a subscript enclosed in square bracket. The subscript of variable name can be either constant or integer variable or integer expression. For example, A0, AI, AI plus 1, A00. The data items grouped in an array are either built-in data type, that is int, float, char, or user-defined type, that is structure, objects. Since elements of an array are distinguished by subscripts only, so they are also called subscripted variables. Array can be one-dimensional or multidimensional depending on number of subscripts used to identify their elements. The syntax of an array is as shown, where data type refers to nature of data elements in an array. Array name is the name of the array. Size declares maximum number of elements that can be stored in that dimension. Thus, array declaration helps a compiler to have information about array name, type of data to be stored in an array, dimension of array and array size. Now let's discuss in detail about various types of arrays available in C++. Vector single dimensional array. Dear friends, can you define a vector? Before explaining it, let's consider some example. Suppose I have 100 students in my class. Age of all of them is different. In order to manipulate this age, you must store them in 100 different locations. Will you create 100 different variables for this? Whenever we have large data corresponding to a particular attribute, they can be grouped together in the form of an array. Vectors are the simplest form of arrays. They are also called as single dimensional or 1D array or linear array because only one subscript for index is used to identify elements in an array. Its syntax is, as we know, data type refers to as nature of data elements in an array. Array name is the name of the array. Size declares maximum number of elements that can be stored. For example, char name 15 means an array name forms a string consisting of 15 characters. Int age 5 means array age is a vector of 5 integer values. As we know, elements of array are referred to by their subscript or index. In C++, first location of any vector is 0, that is, index numbering starts from 0. In the previous example, when we have declared age 5, we can store 5 integer value at 5 different locations as shown. Thus, all the elements in an array are of the same type but their values vary. Each element of the array name age has int data type and it occupies 2 bytes in the memory. First array element has value 3 and the last element has value 10. The subscripting of array elements varies from 0 to 4. But how these values are stored in computer memory? Let's see this also. Memory map of one-dimensional array. Consecutive memory locations are reserved in memory as soon as array is declared. Number of bytes reserved depends on type and size of an array. For example, int age 5, in this case, when array element has int data type, then 10 bytes are immediately reserved in memory because each of the 5 integers would be 2 bytes long. 3001 is the memory address of first array element. Similarly, it takes 1 byte in memory for char data type and 4 for float data type. This we have already discussed in module 1. In general, if base address of array is known, we can calculate the location of an array element by the formula where LOC is the location of vector element, base V is the base address, that is starting address of vector, and I is the subscript. W is the words per memory cell for the vector. Like we have said, it takes 2 bytes and char takes 1 byte. How different values are reserved in array elements? This can be done by 2 methods. First one is array initialization. At the time of declaration, an array can be initialized as any other variable, but initial values must appear in same order in which they will be assigned to individual elements. For example, int days 7 is equal to 1, 2, 3, 4, 5, 6 in 7. Thus, days 0 will have value 1, days 1 will have value 2 and so on. Last location days 6 will have value 7. Just recall that subscript is started from 0. Similarly, char status 2 is equal to MU. We'll declare an array status as character and 0 and first locations of status will have values as M and U. Now see this example. Int days 7 is equal to 1, 2, 3, 4. Here, number of initializing elements are less than size of array. Now what will happen? All the individual array elements that are not assigned explicit initial values will automatically be set to 0, like int days 7 is equal to 1, 2, 3, 4, 0, 0, 0. If array size is not known, even then also we can initialize array as shown. The number of values in the initialized list determines the size of array. In this example, there are 3 different values, that is 2.1, 4.22 and 5.6. So, size of array is 3. Similarly, char status is equal to M, U. Size of array status is 2. Second way to have values in arrays is through user's choice. As per requirements, different values can be inputted in array. Then you can manipulate them and even print them. Input and output of arrays. All the individual array elements cannot be inputted or outputted by using single input-output statements. Hence, arrays can be read or written by reading or writing the elements inside a loop that iterates upon the size of array. Any type of loop structure can be used for this purpose, but for loops are most commonly used. For example, for inputting data in an array is as shown. Here you can see that loop iterates for 7 times from 0 to 6, and in each iteration value corresponding to arrays days I is inputted from keyboard. For example, read out the element of array is as shown. Here you can see that loop iterates for 7 times from 0 to 6, and in each iteration value corresponding to array days I is outputted on computer screen. In other words, you are reading array elements. Now let's write a program illustrating this. Here, after including header files, arrays Q and A are declared, but array Q is initialized also with values 2 and 4. Note that the third value will be explicitly taken as 0. All the values of array Q are printed as 2, 4 and 0. But as we have neither initialized array nor inputted any value in it, so garbage values are printed. Thus, we can say that if an array declaration neither include initialization of array elements nor insert element in an array, then it takes garbage value. Accessing array element. Once you have values in your array, you can always access them, manipulate them, arrange them, or do whatever you want to do with, like in the first case, we have assigned an array element to a simple variable, while in second case, we have assigned sum of 2 array elements to variable x. Here, we have modified an array element. Here, as you know, we have printed on array element. Array element can be accessed in any order and can be used in the same way as simple variables. But size of array once declared cannot be modified. Now let's write a program to find the sum of array elements. Here, after declarations and initializations, user is prompted to specify the number of elements to be stored in array, say n. Then n different numbers are inputted in array with the help of for loop. The number so entered is added to sum also. Thus, if 5 different numbers are stored in an array are 12, 13, 3, 5 and 6, then their sum is 39. Multi-dimensional array. Till now we have seen how we can handle vectors, but can you draw even a single line with the help of vectors? No, my dear friends, you cannot. To draw a line, you need 2 points each with specific coordinates xy in 2-dimensional and xyz in 3-dimensional. Now these points can be stored in multi-dimensional arrays, that is in 2D or in 3D. So whether you are making a circle or a polygon with different edges, you need to store different points in 2D arrays. Of course, these shapes are available in certain graphical packages, but these packages are developed and they use the concept of arrays. Similarly, what about if you want to make a car or an aeroplane or want to simulate a space shuttle? All points in this case will be represented in 3 dimensions. Nowadays, whole of space research is done on computers, and my dear friends, space needs 4th dimension also, that is time. Now can you visualize the significance of arrays? Thus we can say that multi-dimensional arrays have higher dimensions. They are defined in the same way as one-dimensional array, but each dimension is identified by a separate subscript. In general, Multi-dimensional array can be 2-dimensional, 3-dimensional or n-dimensional. But C++ can handle only up to 3-dimensional arrays. A 2-dimensional arrays or matrix arrays are represented in a tabular form with rows and columns which are identified by two different subscripts. Thus we can say in 2D array each element itself is an array. Syntax of 2-dimensional array is as shown. Here size 1 and size 2 represents size of row and column. 2-dimensional array can be declared as either int or char or float, etc. For example, if there are two students and each student appears in two papers, then we can declare array as int stu 2 2. Here name of all the three students is maximum 25 character long. Char stu 3 25. The elements of arrays 2 are stored in 4 different memory locations and are referred to as 2-dimensional array elements can be represented in tabular form as shown. Initialization of 2D array. 2D arrays can also be initialized at the time of declaration by their declaration being followed by a list of initial values enclosed in braces. The initialization is done row by row. All the individual array elements that are not assigned explicit initial values will automatically be set to 0. Number of elements in each pair should not exceed the defined array size. Alternatively, we can also declare them as follow. If array size is not known, even then we can initialize array as shown on the screen. But in such cases, column dimension is necessary while dimension row is optional, as in above case where row size is not fixed while column size is fixed as 2. Memory map for 2-dimensional array. Elements of any dimensional array are stored in continuous memory locations. So arrangement of array elements of 2D array in memory is as shown. By this type of memory representation, we can easily refer to the value corresponding to an array student. In general, if base address of array is known, we can calculate the location of any m star and matrix element by the formula, where LOC is the location of vector element, base mat is the base address, that is the starting address of matrix, and I and j is the subscripts. Thus, the value of stu 0 1 is 5. To input the data in 2-dimensional array and then print each element, the program is as shown. In this program, user is prompted to specify the size of 2-dimensional array in form of rows and columns. Elements are entered in nested for loops. Similarly, elements are printed in nested loops. The first loop corresponds to row and second correspond to column. Thus, if number of rows and columns are 2 and elements are 2, 3, 5 and 7, then contents of array are as shown. 3-dimensional array. An array having 3 dimensions is called 3-dimensional array. In other words, we can say a 1-dimensional array of 2-dimensional arrays is called 3-dimensional array. The syntax of 3-dimensional array is as shown. We can declare and initialize 3D arrays as the outer array has two elements, each of which is a two-dimension array of three one-dimension arrays. Figure helps to understand this situation better. Data can be inputted or read with the help of third level nested loops specifying each dimension by a different loop. Just now we have seen the significance of arrays and how we can use them. Now you try your hands in crafting different programs consisting of arrays. Goodbye, see you in next module.